are going to look at now lesson 5. So it's graphing using technology. Here we have trends using technology. So is your study time and mark related? The following data was collected. So we're going to use Excel. You could use Google Sheets for this, up to you. But the first step says create a scatter plot and add a trend line. So in Excel, I have my data here. I'm going to create a scatter plot. So highlight, insert, charts, scatter plot. Technology is great because that would take you a longer time to do. I'm going to change the title by double clicking. And the title will be study time versus marks. And I could do quick layout. And I just click the layout there of what I want. I actually don't need the series there, but I can now add my title of the x-axis, which is study time, and that's in hours, and marks are on my y-axis. That's percent. Okay, so then the next part says add a trend line. So I can click my chart. There's a plus sign here. I click the plus. I go to trend line, but I'm going to click more options. So I click that little arrow and I can do different things here, but I'm going to click more options. It's not what I wanted. Second, unclick trend line. So click more options. Why does it keep doing that? There we go. Okay, so I'm at the bar graph there. You can see the different trend lines. I can pick different ones, polynomial, logarithmic, linear, exponential, but we've been starting off with linear. So let's look at what the linear trend line looks like with regards to my data points. I'm going to scroll down, and we did calculating R values and equations by hand. This is the beauty of technology. You click your buttons, and those are there. You still need to know how to do those by hand because you won't be using technology on your test. You'll have to show your work and give me the equations and your R squared values, but that is how we would do it by using technology. So if I go back to the note, here you can see the equation of the line of best fit is y equals 4.7143 x plus, and I'm just going to use 55. The coefficient of determination is r squared, so that's 0.8589. That's calculated in Excel here. Okay, so I just pulled those values here. Is the linear model a good fit for the data? Why? Right now, it does look like it's a good fit. Yes, we have a strong positive correlation. 0.8589. What is, where was it, correlate? Oh, sorry. R squared was 0.8589. So then that's going to come out to 0.926. So the square root of that would be 0.92, let's just say 7. Is the linear, oh, I put this answer here. That's why I'm confused. This answer goes there. Yes, it has a strong correlation coefficient, 0.927. Now it's going to ask me to make a residual plot. So I have to do a little bit of work here still. So I'm gonna, actually, I can probably copy and paste this into my note here. Oh, let's not move that. Okay. Just paste at the bottom here so you have it for your reference. Okay. So that is study time versus marks. Now I'm going to create a residual plot. So I actually need to input this equation. I don't need R squared, but I need to input that equation because we have to find the difference between the calculated and the actual. So to do that, I'm going to create an equation in the first row here, equals, we have 4.7, I'm just going to round here, star, so times, star means times, the x value plus 55. So I get the residual that to be 55. So the calculated would be 55. And if I just highlight that down, it automatically fills that in for me, which is lovely. And then I have to find the residual. So the residual is going to be equals to the actual y minus the calculated. So I get a difference of -5. And again, just drag it down from the corner and I have my residual values. So now I can create a residual plot. The residual plot still includes study time. So I'm going to highlight that. I'm going to press Control, which allows me to highlight two columns that are not next to each other at the same time, and highlight my residual. I'm going to create a graph again, and this is my residual plot. I also want to add in an axis to that. Don't need this series. The axis title on the X would be, sorry, on the Y would be residual versus study time, which is in hours. Okay, and so for this, we can see a pattern. And so a reminder, when you can see a pattern, let me see if I can actually copy, and I'll paste this for your reference down below. So when you can see a pattern, reminder that the model that we originally chose is probably not the best model. So we originally chose a linear model, linear regression. This shows a pattern, so there's probably a better model out there for us to use. So I'm just going to write here that there's a pattern in the residual plot. Therefore, there is, or there may be, a better model to use. We still had a high correlation coefficient with our linear, but there's probably something better since we're seeing a pattern here. So it says add a polynomial trend line of degree 2. So let's go back to our graph. I'm going to click the plus here, more options. And instead of linear, I am going to now click polynomial. So if I look here, I can see a polynomial. I'm also going to display the R squared and my equation. Okay, so let me just make sure my values look okay. Yeah, so that you can see that plot there. That looks a lot more like a parabola than, oh, actually, that's not what I want to do. Sorry, that's not what I want to do here. Let's go back. I actually wanted to take my original values. So let's take our original values, and I'm going to, let's move these down so we're not confused. I'm going to take my original values. I'm going to plot this again. Insert, scatter plot. But this time I'm going to create a polynomial. Okay, so instead of polynomial order, degree 2, instead of linear. So I'll show you, let's display these R squared and there. Okay, so if you look here now, the original versus the second one, you can see almost all the points lay on this parabola, and you can see the R squared value is 0.99.14. Okay, so we forced a linear model in the first one. That's what we're used to. We're trying a polynomial next. If this didn't work, you could try an exponential. You could try different types of graphs, but this polynomial was guided to you for you to do that. So that actually works better. You can see all the points actually almost fall on that trend line there. So I added that. What is the coefficient of determination? It was 0.9914. Right, 9914, good. And then what is a correlation coefficient? It says careful here, because you actually can't have an R when it's nonlinear. Can't, so there is none. Have an R value if it's nonlinear. Okay. And what is the best model? The best model we would say is the quadratic. The linear was kind of showing a good R value, so that was close, but this would be quadratic because almost all your points are now on this trend line of your parabola. The quadratic is your best model, and the points almost all sit on the curve. Okay, so this is how you can use technology to create your trend lines, regression models. It's very useful, but it won't be on your test because it's just a hard thing to test. If you continue to look, you'll see there are homework questions to practice. You should have an understanding of this to meet curriculum expectations. And that is lesson 5.